Okay, guys, welcome back. Okay, I think I actually was doing everything fine, so I just double checked it over here. I think I made a mistake when I was plotting my points, though. So here's our function, and our mapping notation was correct, and these were the same points that we had from before. So first point is negative 6, 5, which goes here. And then we have negative 4.5, 5, which would be here. And then we have negative 4, 7, which is here. So these points are going like this, and then up to this. And we have negative 3, negative 1, negative 3, negative 1, which goes to, it's going to come down like this. And then we have negative 1, positive 3, which comes up to here. So this graph is going to look like this. Okay. So for these type of questions, when we're given a graph and want to sketch the new graph, we're going to write out our mapping notation and then kind of apply the mapping notation to some key points on the graph and then sketch the new graph afterwards. Similar idea over here. So we want g of x equals 1/4 f of, I'm going to factor out this negative 1/2, and this becomes an x minus 2 plus 25. So our mapping notation is going to be xy becomes negative 2x, and then we're going 2 to the right, so this is going to be plus 2 times 1/4 y plus 25. Okay, so there's our mapping notation for this function. So we have 4 points we're going to apply this to. So we have negative 4, negative 20. We have negative 2, 56. 3, negative 69. And we have 6, 120. Okay, so applying this, negative 2x plus 2. So negative 4 times negative 2 is 8, plus 2 is 10. 1/4 times negative 20 is negative 5, plus 25 is 20. So our first point is going to be 10, 20. 10, 20 will be right here. Okay, next points. We have negative 4 plus 2 is 6. 1/4 of 56 is 14, plus 25 is 39. So 639 will be approximately here. We have negative 6 plus 2 is negative 4. Just going to do this one on my calculator here. So 1/4 times negative 69 plus 25 is 7.75. Negative 4, 7.75 will be about here. 6 times negative 2 is negative 12. Plus 2 is negative 10. 120 times 1/4 is 30, plus 25 is 55. So we get negative 10, 55. So 20, 40, 60, 55 is about right here. So we're going to get this graph that is another polynomial function, and it looks like something like that over there. Okay, that drawing wasn't great, but that's how this guy works, like that. Okay. Example 5, given f of x equals x cubed, sketch the graph that has been vertically stretched by a factor of 8. So this point 2, 8 can come way up over here, probably off the screen, to like 64 over here. 1, 1 is going to come to 1, 8. Let's put this here. And then 0, 0 is going to be invariant. Negative 1 is going to become negative 1, negative 8, which will be here. And then negative 2, negative 8 is going to come way down over here. So this graph's going to look something like this. Okay, so this is going to be, I'll call this y equals 8 f of x. Okay, so here's my vertical stretch by a factor of 8. Second one, where we have sketch graph that's been horizontally stretched by a factor of 1/2. So it means I'm multiplying my x coordinates by 1/2. So if I do this, 2 times 1/2 comes here. 1 times 1/2 comes here. This guy's invariant. Negative 1 is going to become over here, because my drawing was not perfect over here. Negative 2, negative 8 is going to come to this guy over here. So the point we're trying to get is, when we do the same thing, we're seeing a directly overlapping graph over here. And this is going to be y equals, so if I have a horizontal stretch by a factor of 2, this is going to be f of 2x, because that means my b value is going to be a 2 here. Okay, so the point we're trying to get at over here is that in this case, for f of x equals x
Pardon
cubed.
the interruption, staff and students. Life Touch is now ready to move on to grade 12. So all grade 12, last name A and B, please proceed to the cafeteria.
So we have 8f of x equals f of 2x, which is like, i.e., a vertical stretch of 8 is equivalent to a horizontal stretch by 1/2. Okay. Algebraically, why does that work? What's this equal to? 8f of x equals 8x cubed. Well, f of 2x equals 2x cubed. If I apply this cube to the brackets here, that's the same thing as 2 cubed is 8x cubed, like this, okay? So you can see it graphically here. When we stretch it by a factor of 8 and we stretch it by a factor of 1/2 horizontally, we get the same picture. And algebraically, we'd see that an 8f of x is going to equal a same thing as an f of 2x for this function here. Now, the point we've got to make over here, this is not for all functions. This is specific to this function of x cubed over here, okay? So throughout this unit, one of the harder concepts to say is this idea of equivalent transformations and how they work out. So equivalent transformations are when two different transformations are applied to a function and the resulting graph is the same. Okay, so in this case, if f of x equals 3x plus 1, f of x minus 2 equals f of x plus k. So what this is saying is a horizontal translation of 2 right is equivalent to some vertical translation. I'm saying some because we don't know what the k value is. And the next part B, is saying to actually solve for k. Take a look at this one graphically here. 3x plus 1 is a linear function. So our graph is slope of 3, y-intercept of 1. So this graph looks like this. Okay. So if I translate this guy 2 to the right, that means this point would go here. This point would go here. And we get this graph over here. Now, I think what you're saying is, like, you see, like, at this point, if I take this point and drag it down here, we're going 1, 2, 3, 4, 5, 6, I'm getting this point over here. If I take this point and drag it down 6, 1, 2, 3, 4, 5, 6, so the point is that if you look at it graphically, the answer appears to be a horizontal translation of 2 to the right is the same as a vertical translation of 6 down. Here's how we do this one algebraically. So let's take a look at f of x minus 2. So what I'm doing over here is I'm replacing x with x minus 2. So f of x minus 2 equals 3x minus 2 plus 1. Okay, so cleaning this up, this is 3x minus 6 plus 1, which is 3x minus 5. Now what we're saying is that this is the same thing as f of x plus k.
That was a quick group. We're ready for grade 12, C, D, and E. Please proceed to the cafeteria.
So we need to figure out what this k value is here. So what we're going to do is we're going to take our f of x value which is 3x plus 1, and make this substitution in here. So we get 3x minus 5 equals 3x plus 1 plus k. Now I'm just going to subtract 3x from both sides, subtract 1 from both sides. 3x's cancel out, minus 1, and we get negative 6 equals k, which is what we saw graphically. This is telling us that we have a vertical translation of 6 units down. So this point going 1, 2, 3, 4, 5, 6 is taking us to this point over here. Okay, so we are getting an equivalent transformation in this question over here too. All right, let's move on. So here's a past diploma question. Transformations given by mapping xy equals x plus 4 negative y plus 3. Determine the possible transformations below to indicate the correct ones in the below. So what the mapping notation is saying is that my x value goes 4 to the right. That's telling us the same thing as that we have an f of x minus 4. Now, if I have negative y plus 3, means negative y means reflection, so I'm multiplying my y's by a negative. So that's a reflection in the x-axis. I'm going to have it like this, and I'm going to have a plus 3 like this. All right, so what does this mean? Horizontal translation, 4 right. We're going to have this. We're going to have a reflection in the x-axis. That's this. And we have a vertical translation of 3 up. This. So this answer should be 2, 6, 7. Okay, example 8. Given g of x equals a f of b x minus h plus k, determine the values of a, b, h, and k. All right, tricky question here. But let's go ahead and figure out what our a value is going to be. Now, looking at this, the a value is all about our vertical stretch. If we look at from this point, our f goes from here up to here. So I'm going to say, like, if I say this graph has a height of 5, well, so does this graph. Okay, so it goes from negative 4 up to 1, right? So this guy also has a height of 5. So this is telling me that we just know that our a value is just 1. There's been no vertical stretch applied over here, so our a values can stay the same at 1. Let's look at our kind of the width of this function. So this one originally goes from 2 to 9. This guy is 7. Okay, well, this guy goes from negative 1 to 2.5. So this width over here is 3.5. So if it was this distance from here to here is 7, and now this distance from here to here is 3.5, I hope you can see that my horizontal stretch factor must be a half. So my horizontal stretch factor equals a half. Therefore, b equals 2. Okay, so here we have so far. We have y equals f of 2, and we do not know my h values, or I don't know the k values here. Okay, now what would happen? So this point is starting here, and it's ending up over here. Well, what happens to what's this 2 going to do? The 2 is going to give this guy a horizontal stretch by a factor of a half. So if my x coordinate is 4, it's going to stretch this guy to 2, okay? And then this guy is going to be moving 2 to the left to have an x coordinate of 0. So I'm going to say that therefore my h value is negative 2. I'm going 2 to the left. So again, if I apply my stretch, this guy gets stretched by a factor of 1/2, comes to here. But then the y value is 5 here, but now it has to get pulled down to a y value of 1. That means k is going down 4. That means k must be negative 4. So our equation is going to be y equals f of 2, x minus negative 2, so I'm going 2 to the left, so it's going to be x plus 2 minus 4. Okay, and this is how this graph works. 9, quite difficult. We're going from the green graph, f of x, into the purple graph of g of x. Same idea. Let's look at this. There's been a vertical stretch. My green graph goes from here to here. And I'm going to say that there's a height of 4. My purple graph goes from here to here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is a 12. So I know that my vertical stretch factor is going to be 3 because I'm going from 4 to 12. Now also, if you see this graph is kind of like opening up for this part and now it's opening down for this part over here, that means there's also been a vertical reflection. So I'm going to say that my A value is -3. Okay, let's look at my horizontal stretch over here. So here I'm going from -5 to 6, which is 11. Here I'm going from -4, and so I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 as well. Okay, so there's been no horizontal stretch in this case, but look over here, like this curved part of my graph is on the left side, but now it's on the right side. So that's telling me there's been a reflection in the y-axis as well. Now what I'm going to do here, guys, I'm going to kind of do this next part algebraically because I think it's going to make it a bit easier over here. If you look at our mapping notation so far, we have y equals, this is a reflection in the y-axis, and we don't know what this h value is yet. For my y's, I'm multiplying it times -3, and I'm adding a k value. Okay, so what I'm going to do is let's look at this point here, which is -4, -3, and this point here, which is 6, 5. So if I input this point, I should get this point following this mapping notation. So I'm taking my point of -4, 3, plug it into here, -4 plus h, comma, -3 times -3 plus k. Well, this should equal the point 6, 5. So that means this part corresponds with this -6, and this part corresponds with the 5. So I have -4 is 4 plus h equals 6. Subtract 4, that means h equals 2. -3 times -3 is 9 plus k equals 5. Therefore, k equals, subtract 9, -4. So our equation at the end of this is going to be y equals -3, f of negative, x minus 2 minus 4. And this is going to be the equation for this transform graph over here. All right, guys, I know this is definitely a longer lesson over here. I hope this makes sense, guys. And as always, guys, send me a message or talk to me in class if you have any more questions, and I'll see you in the next video.